Just imagine only 20 to 25 years ago, whenever people heard the words electric car, they pictured a slow, small, and boring vehicle. But today, those same electric cars can accelerate like supercars. So what really changed? Was it only the bigger battery, or is the real secret hidden inside the motor? Recently, Tesla's new carbon fiber sleeve motor has become a major topic of discussion in the engineering world. Many experts believe this is not just a faster motor, but a technology that could remain a big challenge for other companies for many years. But what is so special about this motor that even the biggest automakers have started taking it seriously? In this video, we'll explain in simple language what problem had been hidden inside electric motors for years, how Tesla solved it, why carbon fiber is getting so much attention, and why simply opening Tesla's patents doesn't mean any company can build a motor like this. Stay with us until the end, because we'll also understand whether this technology is only for high-performance cars or if it could change the future of the entire EV industry. Let's understand it in detail. And before we move ahead, make sure to subscribe. If someone looks at today's Tesla Model S Plaid and says, "Electric cars have always been this fast," that would be completely wrong. If we go back a few years, the first electric cars were nothing like today's EVs. Around 2003, most EVs were designed for short city trips. They had low speed, limited power, and couldn't travel very far on a single charge. At that time, people believed electric cars were only good for everyday short-distance driving, not for long journeys or strong performance. Then, little by little, the technology started improving. Batteries became better, electronics advanced, and the biggest change was seen in electric motor design. In 2008, the Tesla Roadster began changing people's thinking. For the first time, it showed that an electric car was not just a way to save electricity, but could also deliver impressive performance. Its range and speed attracted the attention of other automakers. After that, Tesla kept improving its motors and control systems. The results became clear with the Model S and later the Model S Plaid. The Plaid became famous for its acceleration because it can go from a standstill to 60 miles per hour, or about 97 kilometers per hour, in just a few seconds. But the real story is not just about being fast once. The important part is that the motor can keep delivering the same power again and again without overheating or losing its performance. Many people think an EV's power comes only from its battery, but that's not the complete picture. The battery stores energy while the motor delivers that energy to the wheels. Even if the battery is excellent, the car can never show its full potential if the motor cannot use that energy efficiently. That's why the battery and the motor must work together perfectly. Over the past 20 years, electric motor technology has improved through many small advancements. Better magnets, more efficient control software, faster inverter processing, and designs that remain stable at high RPM have greatly improved the performance of electric cars. That's why today's EVs are faster, more reliable, and more energy efficient than before. This is also why engineers are no longer focused only on building bigger batteries. Today, they give just as much attention to motor capability, efficiency, and engineering. The biggest problem hidden inside the rotor. First, let's understand what actually happens inside an electric motor that decides its overall power and performance. Every electric motor has two main parts. The first is the stator, which stays on the outside, and the second is the rotor, which spins rapidly in the center. When the stir creates a magnetic field, it makes the rotor start spinning. This spinning force is what finally reaches the wheels and moves the vehicle forward. That's why if the rotor does not work properly, the performance of the entire motor is affected. Most electric vehicles on the road today use copper windings and a silicon steel core inside the rotor. Copper carries electricity very efficiently, while silicon steel helps manage the magnetic field more effectively. This design has been used for decades because it is reliable and also easy to manufacture on a large scale. But the real challenge begins when the motor starts spinning at very high speed. As the RPM, or revolutions per minute, increases, the centrifugal force acting on the rotor also rises quickly. In simple words, the faster the rotor spins, the stronger the force trying to pull it outward. That is why every part of the rotor experiences very high mechanical stress at high RPM. If this stress keeps increasing over time, very small changes begin to appear inside the rotor. Many times these changes are not even visible to the naked eye, but their effect can clearly be seen in the motor's performance. Even a small imbalance in the rotor can increase vibration, create more noise, and make the motor run hotter than before. This extra heat also leads to more energy loss. That is why engineers do not focus only on making a more powerful motor. They also make sure the motor remains stable for a long time. If the motor keeps overheating or produces excessive vibration, its efficiency starts to drop. In other words, part of the battery's energy gets wasted as heat and friction instead of reaching the wheels. This has been one of the biggest challenges in motor engineering for many years. On one hand, companies wanted the motor to spin at higher RPM to deliver better power and faster acceleration. On the other hand, keeping the rotor safe and perfectly balanced at those high speeds was not easy. That is why increasing motor speed was never just about software or the battery. The strength of the rotor and its design were just as important. Trying to solve this challenge in a different way eventually opened the door to new motor technologies. How exactly does Tesla's carbon fiber sleeve work? This is where Tesla took a different approach. Instead of only trying to increase the motor speed, the company focused on strengthening the part that experiences the most stress, the rotor. To do this, Tesla used a carbon fiber sleeve. In simple words, it is a very thin layer of carbon fiber that is fitted very precisely around the outside of the rotor. Its job is to keep the rotor in its correct shape even at very high speeds. Carbon fiber is well known for its strength. Its tensile strength, or the ability to resist pulling forces, can reach around 2,400 megapascals, which is much higher than many common engineering metals. That is why it is also used in aircraft, racing cars, and other high-performance machines. Tesla tried to take advantage of the same property in its motor. The interesting part is that this sleeve is only about 2.5 millimeters thick. It may look very thin, but its role is extremely important. When the rotor spins at very high speed, the sleeve holds it tightly from all sides. This reduces the effect of the outward forces acting on the rotor and helps it keep its shape stable. Here's a simple example. If something is tightly wrapped from the outside, it becomes less likely to expand or move. The same thing happens inside the motor. Engineers call this preload. In other words, the carbon fiber sleeve applies controlled pressure to the rotor from the beginning. This pre-applied pressure helps keep the rotor balanced at high speed. According to Tesla, this design allows the motor to operate safely at around 22,000 revolutions per minute. At such high speed, the biggest challenge is not just spinning fast, but staying stable all the time. If the rotor remains balanced, the motor can deliver power more effectively, produce less vibration, and generate comparatively less heat. The carbon fiber sleeve is not considered just a new material. It is an important part of the entire motor design. A structure made from regular metal experiences higher mechanical stress at high RPM, while carbon fiber provides much greater strength with less weight. This helps the motor run more reliably at high speed. However, this technology is not easy to manufacture because the material is important, but precise manufacturing is equally important. Why does not just speed but also efficiency increase? Many people think that if a motor spins faster, it simply means higher speed. But in reality, the benefit of a good motor is not limited to acceleration alone. If a motor is more efficient, it can make better use of the battery's energy. That is why engineers focus not only on increasing power, but also on reducing energy loss. When less heat is generated inside the motor, less energy is wasted as heat. This means more of the electricity coming from the battery reaches the wheels. If the motor starts overheating again and again, its control system may reduce power to protect it. So lower heat is not just about protecting the motor, but also about maintaining consistent performance. Better cooling also plays a major role. If the motor keeps operating at the right temperature, it can maintain its performance for a longer time. This becomes even more important at high RPM. If the motor stays stable while running at high speed, the driver gets almost the same response and power every time. The effect is not limited to the racetrack. It can also be noticed in everyday driving. Whether you are overtaking on the highway, need quick acceleration, or are driving long distances, a motor that delivers consistent power makes the driving experience more reliable. If the motor keeps reducing its power, the driving experience also changes. This also has a positive effect on the battery. When the motor uses energy more efficiently, you can get more effective driving from the same battery charge. This does not mean that simply changing the motor will greatly increase the driving range, because range depends on many other factors as well. But a better motor can definitely make smarter use of the energy stored in the battery. Today, motor efficiency is considered just as important as the battery itself. A good electric car is not only fast, but it also wastes less energy, delivers consistent performance, and feels more reliable in everyday driving. These small improvements together make modern EVs much more practical and effective than before. Tesla's open patents, generosity, or a grand strategy. Now, let's talk about the part that often gets the most attention. Several years ago, Tesla said that if other companies genuinely wanted to help advance electric vehicles, they could use some of its patents. At first, this decision seemed quite different. Many people felt that the company was sharing its technology with the world. But the real question is, does having access to a patent automatically make it easy to build the same technology? The answer is not necessarily. A patent explains the design, the basic principles, and how the technology works. In other words, an engineer can understand how the technology operates, but understanding something in a lab and producing millions of units with the same level of quality are two completely different things. Let's understand this with a simple example. Imagine you get the complete recipe from a famous restaurant. You know all the ingredients and the cooking method. Even then, it does not mean you will get the same taste on your first try. The real difference is not just the recipe, but also the experience. The right equipment, the right temperature, the right timing, and years of practice. The same idea applies to motor manufacturing. Even if a company gets the design, it still needs the same level of machines, a precise production line, a strong quality control process, and skilled engineers. Building all of these can take many years. That is why in the automotive industry, competitive advantage does not come from a patent alone. The real advantage comes from the experience gained through continuous research, testing, and large-scale production. This is what many people call production know-how. In simple words, it is practical knowledge that cannot be learned just by reading documents, but is built through years of real work. So Tesla's open patent policy should not be seen as simply making the design available to everyone. A patent can show the path to a technology, but producing it with the same quality, reliability, and at a large scale is a completely different challenge. That is why understanding a new technology may be easier, but successfully repeating it is still considered just as difficult today. AI robots and micro-precision manufacturing. Now the question is, if the carbon fiber sleeve design is so good, why don't other companies simply make it? The biggest reason is not just the material itself, but the entire manufacturing process behind it. Wrapping carbon fiber around a motor may sound simple, but in reality, it is a highly precise manufacturing task. That is why modern robotic systems and automation are used in this type of process. The carbon fiber has to be wrapped around the rotor in a specific pattern. Even a small variation can affect the stability of the entire motor at high speed. Because of this, machines can perform the job more accurately and consistently than humans in many stages of the process. In this type of manufacturing, AI-based control systems continuously monitor the data coming from the machines. Using information from sensors, they can make small adjustments to the settings whenever needed. The goal is to make sure every rotor is produced with nearly the same level of quality. Micrometer precision is also required here. A micrometer is 1/1000th of a millimeter. In other words, the work is so precise that even a very small difference can have an impact later. That is why the machines constantly monitor the carbon fiber tension, the winding angle or the angle at which the fiber is wrapped, and the temperature throughout the entire process. If the temperature or tension starts moving outside the required limit, the system immediately tries to correct it. After that, inspecting every finished rotor is just as important. Many modern production lines use laser inspection and other measurement technologies to check whether the fiber has shifted from its correct position, whether any tiny cracks have formed, or whether there is any unevenness in any part. If any issue is found, that part is inspected again, instead of being sent to the next stage of production. This entire process is an important part of quality control. Building one good motor is difficult, but producing millions of motors with exactly the same level of quality is an even bigger challenge. That is why in mass production, the hardest part is not just developing a new technology, but repeating it consistently in every single unit. This is why in electric motor engineering today, material, machines, software, and the manufacturing process are all considered equally important. Why are other companies lagging behind? Now, the question is, if this technology is so beneficial, why don't other major car companies adopt it quickly and match Tesla? The answer is not as simple as buying a new machine. The real challenge is bringing the entire manufacturing process to the same level. The first challenge is manufacturing complexity. In a technology like the carbon fiber sleeve, every step has to be extremely precise. The material quality, the winding process, the machine settings, and the final inspection are all directly connected. If even one stage has a small mistake, the performance of the entire motor can be affected. It also requires specialized machines. These machines are different from a regular motor production line, and they cannot be built overnight. Developing, testing, and continuously improving them takes a lot of time and investment. That is why the cost of adopting a new technology is not limited to research alone. The entire factory has to be prepared for it. Production cost is another major reason. In the early stages, building motors based on a new technology is usually more expensive. Until production reaches a large scale, the cost of each motor remains high. That is why companies first make sure the technology is reliable and can remain economically beneficial over the long term. Another important factor is years of process development. Every successful production system is built on years of testing, improvements, and experience. Engineers repeatedly refine the design, adjust machine settings, and solve problems that appear during production. This experience cannot be fully written in a patent or a document. Yield rate also plays a very important role. It refers to how many of the total parts produced in a factory meet quality standards on the very first attempt. If the yield rate is low, both time and cost increase. So, it is not enough to simply build a motor. Every motor must be produced with the same level of quality. Along with this, supply chain and scale advantage also play a major role. If a company has access to the right materials, reliable suppliers, and the ability to produce at a large scale, it can control costs much more effectively. That is why even well-established automakers take time before adopting a new technology. So it would not be correct to say that no company can catch up quickly. But it is also true that closing the gap in this type of technology requires more than just a good design. It also needs years of engineering experience, a strong supply chain, and the ability to manufacture successfully at a large scale. Now, the biggest question is whether a motor technology like the carbon fiber sleeve could become Tesla's biggest strength in the future. The answer is not easy yet because the electric vehicle industry is changing very rapidly. New batteries, better software, lowers cost manufacturing, and AI technologies are advancing continuously. In such a fast-moving industry, it is not easy to stay ahead for a long time with just one technology. However, one thing can certainly be said: motor engineering is likely to play a much bigger role in the coming years than ever before. The focus of future EV motors will not be only on delivering more power. Companies will aim to build motors that do more work with less energy, generate less heat, and maintain their performance for a longer time. If these improvements continue, they could have a positive impact not only on vehicle performance, but also on overall cost. Tesla also does not want to remain just a car company in the future. The company is working on areas such as robo-taxi, AI-based driving, and large-scale automated manufacturing. If such vehicles operate on roads in large numbers in the future, the need for reliable, low-maintenance, and energy-efficient motors will become even greater. That is why the importance of motor technology will go far beyond just higher speed. Another benefit of high efficiency can be seen in operating costs. If a motor uses energy more efficiently and generates less heat, it can reduce electricity consumption, maintenance needs, and the stress on some components over the long term. However, the total cost of a vehicle is not decided by the motor alone. The battery, software, service, charging network, and manufacturing cost are all equally important. On the other hand, it is also important to remember that Tesla is not the only company working on new motor technologies. Many of the world's biggest automakers and motor manufacturers are continuously investing in new materials, better designs, and more efficient manufacturing processes. That is why competition is likely to become even stronger in the coming years. If Tesla continues improving its motor technology, manufacturing, and software, it can certainly gain an advantage. But whether that advantage will last for a long time will not be decided by a single technology alone. In the future, the companies that stay ahead will be the ones that can achieve the right balance between better batteries, efficient motors, faster production, reliable software, and competitive pricing. Now, we'd like to hear your opinion. If Tesla keeps improving its motor technology over the coming years, do you think other companies will be able to close the gap? Or could motor engineering become Tesla's biggest advantage?